Hi, welcome back to the Gabster channel. This is a video about how to test your Gabster TD1 Dac. Make sure it's actually before you connect things or if you did something wrong, and try to figure out how to troubleshoot, how to verify how if your OPA861s are still good or if you have something wrong. Just some basic testing so you can actually help you troubleshoot some of your problems if you're having any. So here we go. We're going to see how this Gabster TD1 measures. So just in case you have a problem, you know what a good one should measure like. So I've got it here on my bench. I'm going to use my bench power supply because it just makes it easier and I can actually sit closer and show you guys what happens. The first thing we're going to do is remove the TD8 chip, just because in case yours is faulty or you burnt it, so it doesn't affect your measurements. So let's do that first. And I don't know if I've showed you before. I remember, if you remember, you just take a little flat screwdriver and just give it a little squeeze on one side, squeeze on the other side, and before you know it, if you keep doing that a little bit here, a little bit there, this thing should just come out. So take that, put that somewhere safe. So now we have nothing connected. So the first thing we're going to do, we're just going to test the leads of the TD1. So we're going to put our tester on ohms. So to see, this is not continuity. There's no beep here. Just regular treasures the. It's like the ohm meter. Just going to flip it around so we can see. So first thing first, let's measure the 15 volt. It's the one that actually probably the most problematic of all. And so what you want to do is just without touching with your fingers, because that could screw the measurements. So it'll fluctuate, and that's normal because there is a capacitor in there. And you see now it just says 2 mega ohm. The M before the ohm is mega. So 2 mega ohm. So it's a very high number. Now, what's interesting is if you reverse them, we're going to reverse them, it should show like almost short and fluctuate again, and then it's going to go like 4 mega ohm. The reason it does that because when the lead's actually charging the capacitors a little bit, so when you reverse it, it actually just discharging the capacitors. It even shows the quick short for a second, and then goes back down to just a high mega ohm number. It's fine. Doesn't matter which one. So that's like a healthy board. Basically, you know there's nothing bad going on here. Now, so basically, because you're trying to check your soldering and make sure you didn't create any shorts somewhere, and same thing. We're gonna check the. This is the 5 volt, the minus 5 volt version, around 20 kilo ohms. And then went down to 2 mega ohms. So just to give you like an idea of what's going on. So as long as you don't have, like 20 ohms or 0 or something like that, you know you don't have a short. But this is when I reverse them again, it will fluctuate again because there is a capacitor in there, so around 2 mega ohms. And when I flip them the other way around, fluctuates again. And it should settle down somewhere again around 2 mega ohms. So that's the minus 5 volt, the plus 5 volt. I believe it's the same. Let's find out. Start with 20 kilo ohms, and let's see, it's actually fluctuating. There we go. Now it's 2 mega ohms. So the capacitor was full and it discharged. And that's a healthy thing. You know, at least the capacitor is working and it's not a bad one. I flipped them, so you're going to see a quick short, but don't think you have a short. Just keeps the leads on, and you should see the numbers go down again, 20 kilo ohms, the same thing. It's going to keep going down till eventually probably will show mega ohms again. Here it is. So the capacitors got depleted. So that gives you an idea of how these leads should test. And if you test yours and it's somewhat similar, you know that it's working and it don't have anything shorted on the board. That doesn't tell you that everything is okay, but at least we rule out some of the things. I've already made a video about testing the UFL connectors. I'll very quickly do that. So I'm just going to put it on one of them here and one on the other, and it should show 0 in the center. If I stop moving, we have a 0. And then the DG is actually the ground, and if I put it on the ground, it should show also 0, so you have a ground connection and a center connection. You also want to make sure there is no short, so you put it again one more time. So you put, this time you're going to put the center and the ground, and make sure that there's nothing. It should be no ohms here, because that should be an open contact. Otherwise, if you have a short, means somehow you put too much solder and two pads are actually touching. So that gives you that troubleshooting, that one. Now let's see some more fun stuff. Is how do we determine if we fried our OPA861s or not? There are some ideas. I mean, being in circuit, it's a little bit hard to detect everything. You can check the pads a little bit, but what I found, one good way to do it is to actually power the board and watch the voltages. So again, this is a healthy one. So I'm gonna use my bench power supply here, and I'm gonna put some power on the leads here. I've got plus and minus 5 volt gonna be coming from my bench power supply here. Just gonna power that on. Just makes it easier to power things on the fly. So I've got it connected. I haven't put the power on yet. So make sure all your jumper caps are on. And we're going to check like when you're checking the DC offset. So I'm going to put this on ground here and on the plus here. It means we are checking this side. I'm going to move my hand a little bit to the side here so you guys can see. And let's just zoom in a little bit, because you don't need to see all the other stuff. So here we go. So I'm going to turn the power on. We need to put this actually on DC this time. So there you go. I have it set on DC now. So what do I have? I have 2.32 volts. So remember, we have no TDA, we have nothing, and we have 2.32 volts. The reason is because the DC offset is actually trying to offset something that's not there, so it's actually causing a voltage. And OPA861, they're actually amplifying it, and that's a good thing. And now we're going to test by removing the DC offset jumpers. Remember, I'm actually testing this side here, which is my right output. So just watch this voltage here. I'm going to remove the DC offset jumper of the one we're in question here. And as soon as you remove it, it should drop down. So now we are at 39 millivolts. So this is very good. What's this telling us? That the OPA861 is working because it's amplifying the DC, it's amplifying the DC offset voltage. And when I take the jumper out and when I put it back on again, see 39 millivolts, I'm going to put the jumper back on, and it's up to 2.32 volts. Now, what would happen if I adjust the DC offset? You should see you're gonna see very small movement, but not a lot, like very little, like I'm turning, it's not moving much. It's not really moving much. The reason is it is moving a little bit, but don't expect it to change tons. Like if I keep turning, I'll probably gonna be able to drop it down below 2 volts. Let's see. Here you go. So it does affect it. Just don't expect major swings. Is what I'm trying to see. I'm gonna keep turning. Let's see how low. So I was able to get it down to 1.8 volts. The reason is the DC offset is only supposed to offset by 300 millivolts, 500. We're not talking this big of a swing, and that's why. So this is normal. But this tells you that the OPA861 is actually amplifying the voltage. It means it's actually working. If you get something different than this scenario, it means something, either your wiring is not right, you fried your OPA861, or something, another disaster strike. For example, if you get like 4 volts here, like 3.8 volts, that's not a good sign. So you should basically, just like what I did, you should be able to replicate what I did. If you're able to replicate this, means your OPA861 is working and it's soldered right. Otherwise, it's either faulty or not soldering it right. Now, bear in mind, removing an OPA861 is extremely difficult. The pads will rip right off easily. Unless you have an airflow heat gun, it's almost impossible. Now let's see how it behaves when we actually connect it to actual power with the TDA. And so I've got it here in the proper installation. I've got even UFL connected and everything. But first I'm going to show you how it would behave without powering the your streamer. So there is no music streaming at all. So it's completely off. The streamer is completely off. And we're going to see how things behave. So first thing, we're going to be checking here check here the left channel, and I'm going to put this thing on ground. This is on positive. Again, checking the DC offset, see how things behave in a normal, when things are good. So the first thing I'm going to do is just turn on. So right now we have nothing because there's no power. I'm just going to turn the 15 volt only on. So I just turn the 15 volt on. And what do I get? I get 0.42 volts. So just so you know. And that should not be affected by the DC offset because we don't have any 5 volts yet running. Now let's turn that off. I'm going to turn the 15 volt is off. I'm going to turn the 5 volts ones are on. So I'm going to double check my connections, make sure I'm not going to fry something. We're going to go through that again one more time. So that's positive, negative. Yes, we are good. So I'm going to turn that on. So again, remember what we did just on the bench test? Again, we got our 2.47 volt on, just like before. Even with the TDA in place. So now let's turn the 15 volt on. You're going to see it drop. So just turn it on and it drops from 2.4 to 1.7. And that is normal. And the reason is because there's nothing streaming. And with that, I don't think you can adjust too much. You can adjust a little bit, but not a lot. Just like before, you can do some minor changes, but don't expect to get to 0 here. You only can be able to change it a little bit more or less. That's about it. And till you actually play music. So I'm going to actually right now turn my streamer on. Now, if I had continuous play on my monitor pi set to on, this would have changed immediately, as if you play the song. But because I don't have it set to continuous on, I just did it on purpose, just in case you don't have a monitor pi. So you're going to have to wait till this thing powers, and you're going to have to play a song. So let's just pause a little bit. All right, so I got my streamer up and running, but I haven't played anything yet. So you could still see it's showing here 1.8 volts. So let's play a song. I press play. You're going to feel it drop. As soon as I play the song, immediately it drops to 0.3 volts. And now you can actually adjust this DC offset. This is manageable now. We've been playing with this quite a bit, and that's why we got almost 300 millivolts here. So I'm going to be changing it. So I'm going to turn it. Oops, turning a little fast here. Keep going. Oh, getting close. And there we go, you're close to 0. You can fiddle around with that. So like I said, this is minute amount, so you don't have to worry. But you can, if you want to do it like perfectly, you can keep playing with it till you get close to 0. There you go, 0 point. Almost there. Anyway, you get the idea. You can pretty much play with that till you get it to 0. But don't fret over 5 millivolts or 100 millivolts. It's not a big deal. your music will still sound great. So this is a normal behavior of how things would work. Now, if you do have a monitor Pi Pro, I strongly suggest you put it on the FIFO Pi on continuous clock on. This way, as soon as you turn the knob on on your streamer, automatically it sends like a signal, and this way you don't get any DC offset. It goes automatically to 0, so you don't have to worry about getting like that bump in your speakers on your amplifier. So here you have it. That gives you an idea of what to expect and how to see if your system is behaving like this, means things are good. If not, means something is not right in your connections. Now, the biggest disasters are caused by if you reverse your 15 volts, if you flip this around, you are going to instantly fry your TDA chip and most likely some circuitry in your FIFO-Q7 if you're running directly from the FIFO-Q7, or possibly from your PCM board, you might burn something there. So it's very important not to do that. Also, there's a possibility you can fry your OPA861 chips, because when the TDA fries, that creates shorts in different ways and bad things happen. So basically, flipping your 15 volt is catastrophic. Means it's a $500 mistake. So think about it. So make sure you check many times before you do that mistake. The other mistake is using a power supply where the negative is somewhat connected to ground. That should not be connected to ground. When I mean ground, means earth ground. Should not be connected to ground. Your 15 volt supply or any of your 5 volt supply should not have any of their negatives or even anything connected to ground. Otherwise, you're going to have a short, because you're connecting the pluses to the minuses. It's kind of, if you think about it, the more you think about it, you can realize that you are creating a short if you have anything connected to ground. So do not power. Another thing is, don't, for example, use one of the 5 volts here to power something else on the streamer board, maybe your like your FIFO-Q7, or maybe power your PCM board. That's a no-no. These should be completely independent, not connected to anything else. None of their prongs should be connected to ground. Same with the 15 volts power supply. And that's been quite a bit of a problem for a lot of people, because somehow they're using some fancy power supply that has grounded somehow or another, and it's shorting things. A lot of people got lucky, nothing happened, but you could easily burn your OPA861. They're almost impossible to remove. You have to have a good airflow gun to remove them, so it's not an easy thing. So if you fry everything and hell breaks loose, text me, message me, and send me an email. I'll try to help you out somehow. Okay, I'm going to quickly show you how things are actually connected. So the 15 volts, so the red is a plus, the black is a negative. Make sure you connect them that way. And if you look at how, let's say it's connected to a UC Pure, for example, you're going to see that, oh, here we go. And if we connect them to UC Pure, you're going to see that they're just connected normally, the plus to the plus and the negative to the negative. Nothing fancy here. It's just normal. So do not flip them anyway around and avoid a disaster. Now let's look at the other ones, the 2 plus 0 and minus 5. What I usually personally do, I put the red wire on the positive, and I'll put the black wire on the negative 5 volt. And the 0 are actually the green wires. I have 2 green wires, so they're zeros. So you can do it that way. I've seen other people use red and black here normally on the plus 5 volt, and they flip them around here. They put the red one on the negative and the black one on the positive, and that's okay too. And what you can do then, so then we're going to flow all the way to here. So So here in my setup, you can see that on the plus 5 volt one, you can see that the plus is actually on the plus, and the 0 green wire is actually on the negative. So that's your regular 0 and plus 5. Now this is the tricky one, the 0 and -5. So what happens is the -5, which is the black, goes on the negative, and the 0 goes on the positive. And that's basically how you can do it. And if you had flipped your wires in here and you put black on, like flipped the red to black and black to red, you can basically connect them normally here, plus and minus. I'll put a drawing and maybe make it a little bit more clear, because one of those mistakes could be very costly, and it's just not fun when things are burning and you gotta buy a whole bunch of things again, and it's a frustrating day. So here you can see a proper connection, just a diagram you can see. If you just pause it and have a good look at it and make sure you are doing the connecting things the proper way. Also, before you flip the switch, just measure your voltages, see how things are going to go out. Maybe another way, if you want, for actually protection. So if you want to test things and make sure you're as safe as possible, what I would do is take all the jumpers from the DC offset here and those 4 jumpers for the OPA861. By taking those jumpers out, you're no longer powering anything here. So if you reverse something, you're not going to burn anything. Don't put a TDA1541 chip either. Turn everything on and see and test your voltages and see, do you have the plus 15 properly? Do you have 0, plus 5 and minus 5 here? And if everything is good, then turn everything off, put your TDA in, put all your jumpers back in, and now turn things back on again.